All right, so integrating is actually just as easy as deriving these. So I'll let you look at these rules for integrating. So if the derivative of e to the x is e to the x, then the integral of e to the x would also be e to the x, right? If they just keep going back and forth. It's like never ending. Now, if you have, remember, if we have a derivative of e to the x with some function inside of it, then we need to have the chain rule. So when you see an integral that has the derivative of something in it, we know that it's going to go away as we go up. So you might use the reverse chain rule. We didn't talk too much about it. I prefer to use substitution in here. It's just more clean cut. So we'll do that. And then if you have something that is not e, this is what we do, because remember, if we take the derivative of a to the x, we multiply it by ln a. So when we take the integral, we're going to have to divide by ln a to account for that. It's just the opposite. And then same thing here, we just look for that hook on. Okay, so let's look at our first example. So we're going to find this definite integral. So the first thing we do is we realize that the formula, I guess you could say, for the antiderivative of a to the x dx is a to the x over ln of a plus c. So here we have, oh, and I forgot that there's an inside function. So do we just have 4 to the x? We don't. We have 4 to the x squared minus 1, which is a function, right? So in this case, I'm going to use substitution. You could use the reverse chain rule and just like recognize that this is the derivative and then you have to add stuff. Substitution is easier, I promise. Okay, so u is the inside function, x squared minus 1. Therefore, du is 2x dx. Therefore, dx is du divided by 2x. Okay, all I did is do kind of our u substitution process, right? So everywhere that there is x squared minus 1, I'm going to replace it with u, and everywhere there's dx, I'm going to replace it with du over 2x. So I'm going to end up with the integral of 4 to the u times x, and then instead of dx, I have du over 2x. Okay, the x's cancel out, and I end up with 4 to the u du. I have the integral, and I have it all over 2. Remember, that's a constant, so I can bring it outside. And the only thing left to do is to change my limits of integration, because this is a definite integral. Instead of going back and plugging back in the x squared minus 1, I can just change my limits of integration. So when x equals 0, I have 0 minus 1. So when x equals 0, y equals negative 1. So our new limit of integration is negative 1. And when, not y, sorry, u. And when x equals 1/2, I get 1/4 minus 1, which is negative 3/4. So my new limit up here is negative 3/4. And now I can just go ahead and integrate. So the integral of 4 to the u is 4 to the u divided by ln of 4. We still have the 1/2 multiplying by the outside. And we're going to evaluate this from negative 1 to negative 3/4. So you're like, I don't know how to do that. Well, it's actually not too bad. So we can rewrite this as 4 to the u over 2 ln of 4, because, top times top, bottom times bottom. So we get 4 to the negative 3/4 over 2 ln of 4 minus 4 to the negative 1 over 2 ln of 4, and that's as far as we need to go. Okay, let's integrate this one. We have e to the something, and we need to go backwards, and unless it's e to the x, we're just going to do a u substitution, because we need to account for that, the chain rule. We need to reverse that chain rule. So we're going to do a u substitution, but first let's just rewrite this as the integral of e to the 2, sorry, not negative 2, e to the 2 times x to the negative 1 times 1/3 x to the negative 2 dx. So I just brought everything up top so I can just see it a little better. And so then I'm going to recognize that 2x to the negative 1 is going to be my u because I see its derivative, which is x to the negative 2 next to it. So I'm going to take that 1/3 out of my integral, and I'm going to get, we'll do our u sub over here. U equals 2x to the negative 1, which means du equals negative 2x to the negative 2 dx, which means dx equals du over negative 2, on the right, x to the negative 2. Okay, so everywhere there's a dx, I'm going to put that. So, I just noticed this right behind my head. There you go. All right, so it's going to be e to the u, and then I had it times x to the negative 2, and then everywhere there's a dx, I'm going to put du over negative 2x to the negative 2. And then I'm going to recognize that those x to the negative 2's cancel out, and that this negative 2 in the basement is really the same as negative 1/2. So I'm going to bring that outside the integral so that I don't have to deal with it. So I took care of that, and so now I have negative 1/6 times the integral e to the u du, and oh my goodness, is this not the easiest thing you've ever seen? What's the integral of e to the u? It's e to the u. So I have negative 1/6 e to the u plus c, but I'm not done because I did a u substitution, so I need to substitute back in. But my u was 2x to the negative 1, so I have negative 1/6 e to the 2x to the negative 1 plus c, and we could even rewrite that as negative 1/6 e to the 2 over x plus c. And then we are done. Okay, last but not least, we have this one. And you're like, oh my goodness. Okay, so but do you notice a function and its derivative somewhere? So this inside function, remember this is like a function inside of a function, so the outside, the chocolate is something to the 4th, and then the peanut is the e to the x plus e to the negative x. And so I noticed that this inside function might have its function in this integral. And so I just see, I think that the e to the x plus e to the negative x is the peanut. I really think that is the inside function. So let's try that. U equals e to the x plus e to the negative x. We're going to make a u substitution for that. That means du equals e to the x minus e to the negative x, because remember we just multiplied it by the inside, the derivative of the inside function, dx. Okay. Well, that looks promising because that is right here, right? So then dx equals du over e to the x minus e to the negative x. So now I can make a substitution because not only do I have my derivative, but I also have my, I can just change that out for you. Okay, so I have e to the x minus e to the negative x over u to the 4th du over e to the x minus e to the negative x. And looky there, those cancel out. I end up with the integral, the antiderivative of 1 over u to the 4th du. Okay, and the integral of that is, or the antiderivative, this would be the antiderivative of u to the negative 4th du. And so I add 1, which gives me u to the negative 3rd over negative 3 plus c. That's easy, right? And then I just have to replace u because this is an indefinite integral. I have to replace u. So my u is e to the x. I always keep writing it down here. E to the x plus e to the negative x to the negative 3 over negative 3 plus c. And there you're done. Isn't that so easy? Okay, I hope that you found this to be